Okay, so today we're going to talk about machine learning. So finally, we go to like sexier topic instead of like data. We talk about machine learning. Okay. Before I start, have you guys watched the video I sent out? So the Kaggle one and the YouTube one. So how do you guys have any understanding of what machine learning is about? Like, what can you tell me about machine learning? What is machine learning, basically? After you watch the video.
You use data to learn.
You use data to learn. How about the practical usage of machine learning? What can it be used for? Yeah, anyone?
Advertising, if you go to different sites, it learns where what kind of things you would prefer.
What kind of things you prefer? Like predicting your buying behavior.
Yeah.
Okay. Okay, so machine learning can do a lot of stuff. So if you watch a video, they can do like image recognitions, or you can generally learn from the data. Okay. One like use case for Google is they use machine learning to read the house sign, the house number out of the door. So they map the entire house sign of France in 2 hours by image recognitions. So that's one of the things that machine learning can do. Before I go into like really technical details, I want to show you one simple example to predict house price. So if you click on the 2 links that I sent out, do everyone have this notebook? Because I sent out 2 copies. This is the first notebook, and then later on we'll switch to the next one. Okay. Okay. So if you click on the 2 links, the first link is Kaggle, so it shows you and talk about what the data is about. Okay. And the second link is a link to a data sets. Okay, so you can see the data set of the Boston house price, and you have 4 little tabs underneath. Okay. So I want to use this example to let you have a like general feeling of what's machine learning. Okay, if you run the first line of code, okay, it shows you the data sets of the Boston house price. So basically, what you show here is what you can see on the Google document. Okay, and if you click on the Kaggle, it shows you what every column means. Okay, for example, the first column is crime, which means the crime rate of the town, and you have other stuff like what's the industry, how many rooms on average do that area flat got, and like the average age of the house. Okay. So any one of you has bought a house right now, or thought of buying a house? It's quite impossible, but okay, I I sometimes think of it in my dream. Okay, but let's say you want to buy a house now. What's the first thing you need to think about? Basically, it's the price of the house. You have to know whether or not it's a good price or a bad price. Okay, so let's say if you are a real estate agent, and then you look at these data. Okay, there are many factors that can affect the house price. Okay, if the house is older, it's probably worth less. If the crime rate is higher, it means it worth less, probably. And if the house has more rooms, then it's likely to be bigger, and it's likely to be more expensive. Okay, there are a bunch of this kind of factors. And this data sets is basically describing what's affecting the house price. So on the very right hand side, you got the price. Okay, and everything on the left is the features. So all the factors that can affect the house price. Okay, let's say now you are a real estate agent, and I'm asking you to price the bottom 3 houses. Okay, basically, these guys. Sorry, where the question mark is. Okay, like any guess on what the price is going to be, given the features. Okay, I'm talking about first sale and then. Okay, now I have 3 houses that is in the market, and the owner of the house say, okay, we have this kind of, our house has 6 rooms, is 96 years old, and our area has a crime rate of 2.3. Okay, 2.3%. How would you price your house? Like, no clue, right? Because you have too many variables. But that's basically what every pricing in the market is like. Like why do your house worth 5 millions? Basically that's what the market push it to be. But there's also fundamental factors that affect the house price. Okay, so what machine learning really is the machine is able to tell you what's likely to be the price. Okay. Alright. So let's have a look at the full data sets. So just click on here, and then in here I just showed you a correlation matrix. Okay, it just shows you briefly what's the correlation between every variables. Again, you can't see a lot of patterns, right? And again, if you plot a pair plot, basically there's too many variables, and you can't really see a lot of patterns. Maybe you can see like this is negatively correlated, and you look carefully, it's the price versus LASTAT, which is the lowest status of the population. Okay, so if your area is generally a poor area, then your house price is generally going to be less. Okay, so let me try our first machine learning algo, which is very simple. It's called linear regression. Okay, have anyone heard of linear regression? So it's just a straight line, basically. But I'll show you how to implement it in Python. Okay, if you go to the Excel.
Sorry, I need permissions.
Oh, permissions. Okay. Okay, I just sent it out to the email. I hope everyone have it. Okay, can everyone access the dataset? Okay, if you click on the first one, it's called a simple Boston test. Okay, if you roll to the bottom, I highlighted the 3 unknowns that I want to predict. Okay. Which is essentially identical to what I'm inputting here. So in here you see df simple, and then I've inputted the URL. So this URL basically links back to that datasets. So if you have a look at the tail, like the bottom of the data sets, you can see our 3 question marks. Okay, now we're predicting the 3 question marks. So how are we going to do it? If you think about it, column A to M, these are called the features, okay? And these features, or you can think of it as numbers, this number actually contribute to that price, okay? And in machine learning terms, this is called the features. And the price is called the ground truth. Okay, this is the ground truth we're going to predict. And what the algo is learning is the relationship between the features and the ground truth. Okay? So imagine you're a human. I need you to manually come up with the bottom 3 question marks. What you're going to do is basically you read through every single line above and you find how does this number relate to the price. Okay, that's very similar to how machine is learning it. So in the next cell, I'm going to split the data to 3 parts. Okay, the 3 parts is called X-train, Y-train, and X-test. Okay, X-train is all the features from the crime column to the LSTAT column. Okay, this is called the X-train. And on the Y-train is the price column. And X-test is basically the same as X-train, but it only consists of final 3 rows. Okay, if you run it, okay, this is how X-train looks like. Basically, X-train is everything without the Y column, without the price column. Okay, this is a pattern we want to look at to learn how does this pattern relate to the price. Y-train is basically the price, and X-test is basically the bottom 3, which we have the question marks in here. So the highlighted one are X-test, and those above highlighted are X-train. Okay, this is our training data, and everything on top of the question mark is Y-train. Okay, and all we need to do is to call the linear regression, just fit X-train with Y-train, and then you can predict given X-test. Okay, let's try it. Okay, so after I run the cell, Python comes up with the solution that the 3 question marks we're looking for, which means this 3, is 31, 12, and 33. That's the house price Python is predicting. And what I actually did is I get LM, which is the linear regression, and I fit X-train and Y-train into the algorithm. Okay, and finally, after I fit it, I have the linear regression model, and then I use the model to predict, given X test. Okay, that's basically how every single machine learning algo works. Okay, you split the data and you put it into the algo. Okay.
How can we get the coefficients for each?
Coefficients, basically just lm.coeff. Sorry. Oops. Okay, coef. Okay. Okay, sorry. lm.coef. Okay, that's the coefficients. Okay, you probably don't really understand what's going on, and I'm gonna go through. Sorry. Yep.
Why would the pilot automatically know the scope of the extreme?
The scope.
Yeah. Without including the last 3 rows.
Because we fit in X test has 3 rows. Okay. X train is everything above. So basically, all you did is you use the first 47 row as training data, and then you use the last 3 rows as testing data.
Yes, but is it automatically compatible?
Basically, how many rows you fit in, how many numbers it will predict. Yes.
So let's say if I have one more column, like adding more adding more constraint to the LM for the linear.
You mean adding one column into
one more column? I mean, like, for example, maybe
just one variables.
Yeah, one variable.
And it won't be a problem. After you add one variables, if your testing set has that variable as well, then it will just fit in and refit the model. Okay.
So you will take out all the columns that in the S. So S train is taking all the columns that will be.
Yeah, X-train is using all the columns that are the features. So basically, features means the variable that contribute to the final outcome. Okay, if you want to predict house price, features is like the age of the house, the how good is the area, what's the crime rate, how convenient, what's the transportation, etc. Okay. Okay, you're probably very confused by this stage, and I'm gonna start my machine learning presentation. But let's say you know about linear regression, and in machine learning we have something else called like the rest of the variables, the rest of the model. For example, XGBoost, which is the most powerful algo by now. So the concept behind is quite complicated, but the usage is again very simple. You just do like xgb.fit, and basically you fit in the training data and the ground truth, and it's gonna give you the prediction as well. Okay, so
XGBoost is also linear regression.
no, XGBoost is not a linear regression. It's very similar to another algo called random forest, which we'll cover later on. Okay. But for now, you only need to know XGBoost is way more powerful than linear regression. Okay, but it does the same thing, which is predict the 3 numbers. Okay, this is what XGBoost come out, which is 19, 10, and 23. Okay. Okay, now is the moment of truth, because on the next step, you have the answer. So if you roll to the bottom, you can see 3 highlighted numbers, which is the ground truth. Okay, on column O, the number I type in is what the linear regression is predicting. Okay, and on column P is what the XGBoost is predicting, and the highlighted number is what is the ground truth, like what the house price is selling. Okay, so you can see XGBoost, and I think XGBoost is slightly closer to the ground truth number. Okay. And okay, any question with this part? Or is it very hard to?
XGBoost has more parameters.
Yeah, XGBoost has a lot more parameters. While linear regression is hard to tune it. Okay, so if you go back to the code, let's say now I don't limit to like a smaller subset of the data, but instead use the full data sets. You can go back on top, and then on here you can see Boston test, which is a full data sets with 500 rows. Okay. And now with more data, I want to predict more question marks. Okay. So in this case, I'm using the top 497 rows to train my model, and use the model to predict what's underneath. Okay. So if I run it, now I'm running it with the bigger data sets, and I just run the algo the same way. So again, now it predicts a bunch of numbers again. And if you run the XGBoost and the random forest, it comes up with a bunch of prediction. Okay. Any questions for now? XGBoost. If you can't install, just do -pip3 install XGBoost. See if you can get it. If you can't, then no worry. I will teach you how to install it later on. Okay, so actually I reversed the step to show you how to apply machine learning first. I want to show you like the steps, like how simple is it to apply the model. Basically it's just one line, and that's how we do predictions. Okay, and after you have a feeling of the code, I'll start my lecture to help you understand what's going on just now, because I know it's very confusing right now. Okay. Alright, let's move to the next notebook, and we'll start our actual lecture. Okay, and hopefully after the lecture, it will make a lot more sense what we've just gone through. Okay. So let's switch to the other workbook. Okay, so finally is the real introduction to machine learning. Okay, the first question is, what is machine learning? And before we learn how the machine learns, we have to understand how human being learns. Okay. So how do human learns? to oversimplify the two things, human learns in two ways. So the first way is supervised learning. So what's meant by supervised learning? It's learn by instructions, or learn from a teacher, or by reading the books. So let's say teacher teaches you orange is round. Okay, you know what's the shape of the orange. And your mom told you to avoid the strangers. So you know, okay, I shouldn't talk to strangers. Or you read from the books that you know, okay, lions are dangerous, so you should avoid seeing lions in the wild. Okay, so you learn from what people told you, okay, or learn from what you read from a book. There are other ways of learning, which is called the unsupervised learning. So instead of listening to your mom or reading to a book to learn, you just learn by observations. Okay. So let's say you observe a banana and you observe the orange, and by looking at the colors and the shape, you know there are two different things. And somehow you learn how to distinguish, okay, this is orange and this is apple, and no one tells you to do it. You basically learn it from the features. Okay. And in this case, the features is the shape and the color. Okay. And maybe another example is, okay, you were beaten by a dog before. Okay, so now you know dogs sometimes are dangerous. Okay, this is learned by observations again. So no one tell you why to do it, you just learn it from experience. Okay. And the second thing I ask you is, how do humans make a decision? Okay, let's say you are in the wild. Okay, you are like some Asian people ages ago. Right. Again, to oversimplify things, humans make decision in two ways. Okay, one is classification. Okay, you make decision by, let's say you're in the wild, you saw an animal. Okay, you can make a decision to kill it or to avoid it. Okay, if you classify this animal as not dangerous and you can kill it, then you make the decision to hunt it. And let's say if you classify the animal as like dangerous, like lions, bear or something, then you can decide to avoid it because you classify it to like dangerous stuff. So classification is one of the criteria for making decisions. Okay, after classification, we have another decision to make, which is finding the magnitude. Okay, so let's say you're in the wild. Okay, you decide to hunt the pig. Okay, then you have to find the right magnitude, like the perfect distance or the perfect power or angle to throw your arrow to kill the pig. Okay, that's basically how we make decision. We make decision by classification, and we execute the decision by applying a magnitude to it. Does it make sense? But that's the very oversimplified version of how we make decisions. And this is also how the machine learns. Okay, machine learns two things: classification and finding the magnitude, which is regression. Okay. And also this is also how machine learns, which there are two types of machine learning algo. One is called supervised learning, and one is called unsupervised learning. Okay, final question is, what exactly is knowledge? Okay, I think every one of us is quite knowledgeable. We have different like expertise, but like if you put it into a computer, what is exactly our expertise? Our expertise is again actually a lot of categories and a lot of magnitudes. So everything you learn every now is actually a category. So yellow is a category, like color is a category, shape is a category, machine learning is a category. Okay, and lion, like every description is also a category. Like if you say like banana, okay, banana itself is a category because it is a fruit. But again, it is also a food. Okay, it is a category. Or lion is an animal. It's dangerous, loud, and hairy. All of the terms you can categorize, like put them into buckets. But you can also say everything is a magnitude. Okay. Maybe you think like color can't be a magnitude, but color is actually a combination of 3 numbers, RGB. Or maybe you can say banana is very delicious. But delicious is actually a magnitude. You can put it into a spectrum. Like you can put it into scale. This is the most delicious and this is the least delicious. Okay? So what my point is you can quantify everything. By quantify everything, you can allow the machine to understand your knowledge. Also, another concept is what makes a man knowledgeable or ignorant. This guy is from Lord of the Rings, and they say he's very intelligent. And the main reason why people think he's intelligent is because this guy lives more than 1,000 years. Okay, this guy is very old. We have the terms like wise old man because we think old men are wiser. And why do we think old man is wiser? It's because the old man has more life experience. So if you think of it in a machine learning terms, he is more intelligent because he has more data. Okay. So if you want to train a machine learning model, the more data you fit in, the more intelligent it can be. But you can also say someone is ignorant or very narrow-minded. And if you think of it in the machine learning terms, if a man is only exposed, like he lives his whole life in a small town, okay, this means his data set is very biased. Okay, all he saw, all he ate, all the people he met is within that town. So his knowledge is not generalized to the entire world. So you can say this man is very narrow-minded. But again, if you think of it in the machine learning terms, narrow-minded man is a biased model. Okay, because you fit in like a small amount of data or biased data to a model, so a model would make the wrong decisions. Okay. Okay, before we jump to the next section, just make sure you remember these terms. Very important. So I mentioned supervised learning. I mentioned unsupervised learning. And also classification and regression, which is finding the magnitude. Okay, to recap, supervised learning is you learn by what people told you. Unsupervised learning is you learn by observing the differences. Say, classify banana and orange. Okay. Classification is how we make decisions. Okay, we make decisions by classifying situations, and we execute the decision by finding the right magnitude to execute it. Okay. So, what exactly is machine learning now? So, if you put into like a proper definition, it's just an intelligent machine. Okay, let the machine do intelligent decisions. Okay, but one main difference between a machine and a human is a human has a motivation to solve problem. Okay, we solve problem because mostly because we want to earn money, so we solve problem for our boss. Okay, and also there's a lot of different motivation, like we're hungry, we want better flat, or we want a girlfriend, etc. These are our motivations. But for machine doesn't have a motivation to learn. Okay, so you either have to fit it in for them to learn, or you have to design the algo to make them know what's the award, what's the reward. So let's say for AlphaGo, the reason why it can keep on winning is because they have something called a cost function, and you want to minimize the cost function, and like the goal for it to keep going is to get the highest scores. Also, one other thing to keep in mind is machine doesn't have eyes, ears, mouth, etc. So human, you got all the senses to learn. Okay, these are all informations you receive. But machine has no way to see or hear or learn. So everything it learns is what you fit in. Okay. Okay, so machine learning is a new thing. Okay, so it's different from the old, like human learning and the old coding. So human learn from experience, and if you do like a proper computer science, you do coding. Okay, but a machine, instead of learn from experience, it learns from the data you fit in. And the difference between human learning and machine learning is human, we learn a concept. Okay, I'm teaching you a concept now. But machine, it doesn't recognize any words, okay, any sentences. Instead, it learns by learning the numbers. You have to quantify everything, put it into a computer. And in a way, it is an optimized number. Okay. Any question till now? Okay. Again, this is an overview of what's the machine learning algo. So we have unsupervised and supervised. We have continuous, which are finding the magnitude, and categorical, which is finding the category. Okay, on a supervised continuous, we have a regression, which I think a lot of you guys know what's a regression. On categorical, it's mainly a classification. So we have KNN or logistic regression or SVM. I'm not sure if you guys heard of those terms. Okay. And in here we have something called dimensional reduction. So let's say you have a data set with 5,000 columns, okay, and you don't want to deal with that many data. There's a machine learning algo that compressed the 5,000 columns into like 4 columns, which preserve all the variations, which will be taught 2 classes later, okay. Alright, so again, how do we apply machine learning in like more real life situations? Okay, we use machine learning to solve a problem for us, and machine can be trained to do tasks that is almost as good as people. But usually machine learning only do like one single task. Okay, and the good thing is machine learning is very scalable. Once you build it, you can apply to many things, and it won't get tired. It won't complain. Okay, this Google Quick Draw, I hope you guys remember. So basically, it's just Google recognize what you draw, and it recognized by learning the data sets. Okay, so Google knows, the reason why Google knows what you draw is an apple is because it has a huge database of an apple. Okay. If I ask you now, what do you think this learning is? Do you think it's a supervised learning or unsupervised learning? Supervised, because you know the ground truth. Okay. There's a different algo that Microsoft invented, which is detect how old you are. Okay, if you just click like a random, just search for random image, like, and it tells you the age of the person. Okay, sometimes it's not always correct. Do you guys have any people in mind you want to search for? Donald Trump. Okay, 77. Is that correct? Okay. Donald Trump. 71. Okay, at least it's not too wrong. Okay. Okay, let's try one more. Sorry? Li Ka-shing, okay. Li Ka-shing. Oh, okay, this one. 72. Is that correct? Li Ka-shing. Oh, but because he is very rich, so so he never gets old. Okay. But probably this is like a younger photo of him. I'm not sure. But I think what this algo is good at is classify like babies and old people. Like if you have babies, and it's like all 2 years old. And another amazing things, it understands which are the face. Okay. And can you think of one reason why machine can have so much of these data to recognize where is your face? Do you guys use Facebook? Do people tag you on Facebook? And they tend to tag you on the face. That's why Facebook has millions of face data. And that's how they train a model to recognize your face. Okay. And let's say if you search for a dog face, it can't detect any face. Okay, because the model understands it's not a dog. Okay. Another application is like Google Translate. So you know how Google do their translation? Can you think of like a way that Google can train model to do translation? Okay, have you ever been to a website that has both English and Chinese? You can like click on the top right corner and change to Chinese and change to English. And basically all the fields they talk about are the same thing but in different language. So what Google does is it extracts all the pages that has 2 languages and use the language to train the translation. So it automatically has a lot of training data to train to do automatic translations. Okay, this is also a sentimental analysis which I showed some of you guys in the 2 previous lecture. So if you do like type very positive words, it shows you what's the positive, like how positive the sentence is. Or if you type like negative vocabulary, it detects the text is negative. Okay, this is again machine learning. Okay, the logic is something like this. This is a good book, okay, it's a positive. This is a bad book, okay, negative. Okay, it still have some other like application, which for example, the computer can recognize your handwriting. Okay, it can recognize Chinese character to this character. Okay, that's machine learning as well. Okay, I talked about a lot of like different model. I'm gonna have another general scan through of all the model. Okay, first type is called regression, and regression is basically finding the best fit line in a lot of dots. Okay, and these are all the machine learning algo. Another algo is called decision tree. So basically, if you have a lot of variables, it helps you to find the deciding split, to split the data, and to find the root to make the decisions. Okay, but I'm gonna go through it later on for this. So you have something called decision tree. We also have something called clustering, which, let's say you have a lot of random dots, and you want to find which dots are more similar to the other one. Okay, and for example, in this case, the machine figured out there are two groups in these dots. So this is one of the groups, and these are the other groups. Okay, and the model that falls into these categories are k-means, k-medians, or hierarchical clustering. We also have something like dimensional reductions, like reduce the dimension from 5,000 columns to 3 columns. And yeah, basically that's it. So back to our very first question, predicting the house price. If you remember correctly, I split the data into a set called training set, and I split it to another set called testing set. Okay, what it really means is I split the data to training set to train the model. Okay, the training set is where the model learn the pattern, and testing set is where the model make prediction to predict unknown value. Okay. Why is it so slow? Hold on. Okay, something is not working properly. Shouldn't be. Okay, let me restart. Okay. Okay, so can you guys run the cell in here? It's session 6.1.3, using machine learning to solve problems. Okay. Okay. In this example, I tried to find an example that is more reasonable to you guys. So I used some real life price data from Hong Kong. Okay, I selected 7 house, which is in a Hong Kong site, and 4 in the Hong Kong site and 4 in the Kowloon site. And I've attached the age of the flat and the size of the flat. Okay, and then I have a ground truth columns called expensive or not. Okay, so the first column, the price is 8.7 million, so I call it expensive. And for anything below $6 million, I call it non-expensive. Okay. So if we run the data, and if you click on the unknown DF, okay, so basically I have two new houses, which is on the 5th floor and on the 6th floor. One is on the Hong Kong side and one is on the Kowloon side. Okay, and now our task is to predict what's the price for the house. Okay, can you have a guess, like how much would you pay for a house that is 20 years old, 1,500 square feet in the Hong Kong side and on the 5th floor? How much are you gonna pay for it? Like 18 million. 1.8 or 18 million. Okay. Let's say first one I pay 18 million, and the second one, 6th floor, 30 years old, 300 square foot on the Kowloon side. Any thoughts? Maybe like, I don't know, 6 millions or 5 millions. Let's say 5 millions. Okay, it's overpriced anyway. So okay, and in this case we can try to do predictions. And how do we do predictions? First of all, we have to import the libraries. Okay, import scikit-learn library. I have to copy it from the other side. Okay, these are the libraries that we would need. Okay, again, it's taking quite a while. Okay, maybe shall we have like 5 to 10 minutes break while I fix it, and then I'll keep going. Okay.